So we're going to hear another presentation from Marta Alvar Gonzales. She works in the Polytechnic University of Madrid, and she has a master's in electrical engineering at the Illinois Technology Institute in the United States. And now she works as a researcher in TechnoSite, a company which is part of the ONCE Foundation. She is going to give a presentation which is called the automatic personalization of user interfaces for accessible domotic control. Hello, I'm Marta. I want to present an article, and what it's all about is personalizing the different interfaces for interaction. It looks at new channels for communication for the users in the home with different devices, and the system, what it does is adapt the interfaces so that they are fully adapted to the user's needs and the capacities and characteristics of the devices themselves. So, the prototype was developed in Redis. This project was a Senate project which began in 2010, and in this project, which was about creating an interface architecture so it involved different platforms. And within the home platform in which I work, two prototypes were developed. One was teleassistance and one was domotic control, which is the one I'm going to, or the one that I wrote about in the article and the one I'm going to talk about today. What we use is, we use a universal accessibility platform, and this, as I said before, what it does is adapt any kind of device to the user's specific needs. It's interoperable, can be combined with different services, and one of the reasons for having different platforms was to make sure that it would be interoperable with different services. And it's unique because we can access the platform via an ordinary browser, so almost any device can visualize it. First of all, we had to work on the user profile and the profile's capacities and the capacities of the device itself. The accessibility architecture, the most important characteristics of this architecture would be that the input from the platform consists of UML inputs, and the outputs are XHTML. Obviously, not all devices have a browser, but most of them, smartphones, iPads, etc., they do have this kind of inputs and outputs. So what we used as a methodology to develop the prototype was an initial proposal, what we wanted to do. Then we studied related projects, domotic projects, things that were similar to what we were looking for. And we studied a specific case, which is the one that we developed. We wanted to have a trial in a real situation, so we developed kind of demonstration homes where we could test out the functioning of the prototype. And then we developed participation methodologies so that we could find out what the users wanted, needed, what they were looking for, and this was incorporated. And we had the design, development, and installation. Then we had to have the technological validation. We had to get feedback. We had to make sure everything had been done correctly. And then step 7, which was scientific dissemination. And that's one of the reasons I'm here today. In the home that was chosen, it was Metal Tick. This was part of the Domotics and Intelligent Environments group, of digital homes of the Alicante University and FEMPA. Here we can see the architecture of the prototype. We have on the left of all, on your left, the end user who connects using an access device. This could be a computer, a smartphone, a tablet, any kind of thing like that. This is linked to the interoperability architecture, and this obviously incorporates the interfaces, and we have the architecture which is connected to the prototype itself, which has the input area or input point, and this has the accessibility platform elements, and they contact with the items in the home. It has different resources, images, etc. And this follows the way that the interfaces are defined in the platform. From the entrance point, this input, it goes to middleware, which controls the home, the elements in the home. It's linked to the input, and from middleware it goes to the robot, which is really what controls the elements, a lamp, radiator, etc. I imagine we're going to hear later on we're going to hear about things that have been done at Alicante University, so I shall just talk about the platform itself, not so much about how it works at a more detailed level. I imagine other people will talk about that more, and I don't want to bore you. Here we have the initial screen. When you access the platform, this is what you see. It was divided into rooms: bathroom, lounge, kitchen, outdoors, etc. And each one gives access to different devices. So this would be the outline, the structure. We've got In Redes, is our project. It has different platforms, different prototypes, and this gives access to the home, and in the home you have access to each individual room. Here we have an example of the lounge, and we have access to heating, a blind, and a light switch. This adaptation of the interfaces, well, what's interesting about the prototype is that you take the user's profile, and it really adapts the interface 100%. We're going to see different screens with different adaptations. This is a mixed interface because it's got icons and text, but it could be just with icons for people with a problem with the text. They don't like the text, or it bothers them. So, or we could have just text, or it could be high contrast. So we'll see different examples. We could have different sizes of text. This is the small size, small buttons, but we can modify the size of the buttons for people that have problems in the fine motor skills. So it's quite a simple interface, and we wanted to provide as much information as possible in the simplest way. So we talk about the devices. Each device has an icon, and it shows the current status. So in the next screen we can see how the light and the heat changes. So the heat is on and the light is on. Well, the heating is on and the light is on.